Okay, we are live. And Christian, could you make a small comment that the stream's starting? Okay, so scriptable objects. They're a fancy new class type that Unity provides, and what they do is just store data. They're just pure data storage. And you're like, what's so fancy about that? They're data storage that's kept in a file. So it's actually in the project view, in the bottom with all your scripts and stuff. You actually make instances as its own file. So now the benefit of having this data storage is that the data in it will live even if you cross scenes and even if you exit. Well, they don't actually they persist outside of play mode in the editor, not runtime. So if you change a value in the scriptable object, it can actually stay after you stop testing or whatever. And so what you use this for is a player inventory, because you might cross a bunch of different scenes, go through a bunch of levels, but you want that inventory to stay the same throughout each level. You can also put your stats in there, like the player stats, here's your current max health, here's your strength, etc., etc. You could also store the monster stats, because imagine this whole monster type always has the same stats, so here's all the stats defined in one place, and it's nice like that. And yeah, you make these because they'll make data storage much easier. Because without these, your data is just on your script, right? It's tied to your model behavior, which lifetime is sort of tied to the scene. So now it's really hard to keep that data across scenes and stuff like that. So because these are files that actually exist outside the scene, again, you can just store the data in there and then it lives pretty much forever. And it also makes it easier to separate your data and behavior, because your behavior is just like a number cruncher, more or less. So you can plug the data and make it plug in different numbers a little bit more easily. So now let's actually look at the nitty-gritty of the scriptable object. So first off, scriptable object is just some class that Unity provides. It's an abstract class, so you just extend it, and now you have a scriptable object. Just like how you extend mono behavior to get a script, you just extend scriptable object, you get a scriptable object. But there's actually a special thing called an attribute you must list on top of the class. So attributes are sort of this way of tagging extra information of the class that's not really super important of the class. One of the attributes y'all have probably encountered already is serialized field. But the short of it is the attribute we're going to talk about is create menu asset. And so you know how I said that the scriptable object can be created as a file? Create asset menu, holy shit, is how you actually tell Unity, I want this scriptable object listed as a file you can create. So the two main points are, the attribute itself is still a class. So it has two arguments in its constructor, which is the default file name and how you want it to look in menu. So as you can see, file name is just default file name. The menu name is a bit fancier, where it's you can actually list using forward slashes, the exact menu structure you want to see. So I could list it as my game /stats /enemy stats. And if you list it like that, the menu created will exactly look like my game name. You open that up, you get stats, you get your list of different stat stuff. And so it gives you a lot of control on how it looks in the editor of how to create it. And so once you add that attribute, you can actually just right-click in your project view and go through the menu that you just created and find it. In this example, I just named the menu item new stats ex, but again, if you put forward slashes in this string, in the menu string, you can control that structure. So now, a scriptable object will actually seem like the scripts you've seen before. You can have fields that can be edited. you know, after you click on the instance, and you know, it's nothing all that special. But yeah, it's just like any other script except it lives elsewhere. So another important thing to deal with is there's actually data that lives outside of play mode and data that won't. If a field is serialized, which is what a public variable is by default, or has the serialized field property on attribute put on it, your data is now serialized and will persist. Any changes will persist after you exit play mode. So like this is nice if you want to like tune numbers during play mode, like this enemy's too strong. Let me turn that down a little bit. But it can also be dangerous if you have something like health tracked in a serialized field, because your current health and your max health are sort of like these separate ideas. So like you wouldn't want to track current health in a serialized field because the your current health would, you know, decrease and increase. It may differ from your max health, and you don't want that saved if you like leave and exit play mode. But like max health, that's like permanent, and you would, you know, keep that. You may want that as serialized field. The other kind of variable you can have is a non-serialized field, and that is your private variables, your protected variables, and anything with a non-serialized attribute on it. And so what this does is says Unity won't keep track of the version after it exits play mode. It's just going to let whatever happen happen. So when you start up your game again, it'll always be reset and always have like whatever default value you set in the scriptable object. So yeah, everything sort of makes sense so far. I sort of just went on a ramble. Good, good, thumbs up. Okay, let's go to the actual practical portion. So in the Unity package that I gave you, y'all will notice the scriptable object folder. Go ahead and open that as my Unity decides to shit itself. For a brief moment, I didn't even open that. Thanks, Unity. And yeah, go ahead and open the scriptable object scene. You'll see a scene that looks something like this. And go ahead and look in the scripts folder. Just keep that open. We'll be doing modifications there. But as just as a demonstration, right now, so the enemy stats right here are just listed plainly. You know, this is your standard script. You know, I have my health here, I have my attack here. This is what you'd expect for any other script. Also, I have this stats panel over here. That'll display the you know, the given health, attack, and sprite that I show it. So if I hit play, you'll notice that after Unity thinks a bit. So yeah, the max health is updated with the max health of the enemy, and the attack is updated with the attack of the enemy, and you know, the sprite's updated. But you'll notice something is that I had to manually fill in these fields in enemy stat panel. And you know, what if I had to change the enemy? I would have to edit both of them and remember that I had to edit both of them. That's kind of painful, you know. Why do I have to remember all these things of making this correct? And so the immediate option was probably, okay, what if I make this script reference the enemy script? Because the enemy script is, you know, there. I can look on it. I can look at its values. But what if the enemy isn't in the scene? You know, what if I can't actually have that direct reference to it? So like, there's this problem of I need some data, but where do I get it? And how do I fill this in? And so this is where a scriptable object will come in. What we'll do instead of having these explicitly listed in both the enemy and in the stat panel, we're going to make a scriptable object that will store these. And so both of these scripts that need the data can just look at that scriptable object. So let's actually start making the scriptable object. So I'm going to right-click over here in the project view and make a new C# script. And I'm going to call it enemy stats data because I'm out of names and I already used enemy stats. Oops, press the enter key. So now with enemy stats data, I'm going to open that up. And so now we have Unity's default created script, right? Oh, and is anyone waiting for Visual Studios to open or anything? Okay. Yeah, I probably should have had y'all open that beforehand. Well, I'm just gonna... So yeah, this is the default Unity script. So the only thing you actually need to change is instead of extending mono behavior, oh, actually let me zoom into this. Okay. So yeah, if for those of you familiar with more Java oriented stuff, this colon actually says extends. So yeah, this is just your script is actually extending some script base class. So what we're going to do is instead say extend a scriptable object. And also these update and start functions no longer make sense because a scriptable object doesn't get updated, Oh, and as random filler, as people still open Visual Studios, even though I say scriptable objects are pure data, scriptable objects can contain functions. You can have member methods to them. It's in case you want to have like different, control how the data is manipulated or control access to the data, just as you would with any other class. But for our purposes in this demonstration, I'm only going to have data in here, and that's that. So like with the scripts, I'm just going to make a couple public fields that are so that we can edit them. Oh, and actually first, let's actually make this creatable in the inspector. So above the class, let's actually list the attribute. So these, the brackets mean I'm going to put an attribute here, and the attribute we're going to put on is create asset menu, open parentheses, and then we're going to say is item name. Excuse me while I peek at my slides. File name and menu name. Oops. So we're going to say file name is, let's say just, new enemy stats. I'm going to say the menu name is new enemy stats. We're going to be boring. Going to quickly highlight and let y'all type these. So yeah, like I said before, this is an attribute. It just attaches to the class, and then Unity will figure out what to do with it based on this tag that you basically attach to your class. So is anyone still typing? Are you still opening Visual Studio? Yeah. I'm sorry, you might have to just watch the video. Okay, so if we go back to Unity, it'll do some thinking. It might have a compile error because I can't spell. I didn't spell scriptable object correct. Yep, gotta put that T back in. Now Unity will think again. Okay, now that there's no compile errors, you can now that we attach that attribute, we can actually right-click just like we were making a script, but you'll notice there's a new panel. It's way up at the top called enemy stats, and that's actually the scriptable object. This is how we would create a new scriptable object instance. So go ahead and click it, and then let's give it a name, I don't know, circle enemy, because I don't have art assets. So now we have a boring scriptable object. It doesn't store anything. There's nothing going on. It's just a random class I have an instance of, and I'm storing it. So let's actually spruce this up. Let's actually add fields that we can add to. So now, back in our code on enemy stats data, we're just going to add a public sprite. So, yeah, this will have, as with any class, this will now store a sprite. But if you notice and go back to Unity, after Unity thinks, A new field has appeared in our scriptable object. It's a sprite that we can now fill in. So now, in spirit of actually replacing the data the sprite data we have, I'm going to click on the circle and put in the proper sprite, which is this knob sprite that I used for the enemy. So now, it's like any other field in a script. You can fill in stuff, you can have stuff that can be filled in, and it'll keep it. So now we're going to fill in the remaining values that the enemy has, which is public int max health, and also a public int attack. So just add these two fields because we're going to replace what's in the enemy. And yeah, because we're going to make an object that just completely replaces what's in the script. So now with these two fields, we can pop back into Unity. And after Unity recompiles what's there, you'll notice two fields appearing now. And so let's actually fill those in with the health we see on the enemy, which is 10 on health and 5 on attack. So I'm going to click back on my scriptable object, 10, 5. So now, we have data, we have storage, it's persistent, it doesn't change if I, change scenes. But now let's actually make the scripts use these. So go ahead and open the enemy stats script. And you'll notice it's basic data storage. It's just boring. So instead of storing the data directly, it's going to have a public enemy stats data stats. Yep, it's just going to store a reference to the stats that it needs. And also, because I didn't plan this correctly, we're going to actually void start. Because we actually stored the sprite in the data, we need to pull that data back out. So because the class has just public variables, we can just pull the data directly. So what I'm going to do is actually git component sprite renderer dot sprite. So I'm accessing the sprite in the sprite renderer component attached to this game object, and I'm just going to flat out replace it with stats.sprite. So now whenever the game starts up, this script will just pull the data from the scriptable object and replace it. Boring stuff. Now also, let's open up the enemy stats panel. So yeah, you'll notice that, these three fields exist and, they're terrible for actually trying to update everything. So let's replace that like we did in enemy stats with a public enemy stats data stats. And down here, instead of referencing those fields, we're going to reference the data in the stats. So stats.sprite, stats.maxhealth, and stats.attack. And you'll notice I put this in update to illustrate a point you'll understand later. Even though you normally wouldn't do this because, I'm just reading the data once. It shouldn't change normally, but for sake of demonstration, it's about to. Just highlighting the changes for y'all to take it. Anyone still typing? Yes, come in, Robert. Okay, no. Now he's just referenced in the stream, and everyone will be confused. Okay, so now that we changed how the scripts pull data, let's actually update them in the scene. So yeah, now here you'll notice that it has a field looking for an enemy stats data. We can click the dot and click on our circle enemy one. And same with the enemy. We can put in the circle enemy here. And again, for the sake of demonstration, I'm going to actually remove this sprite that's already here. So now, if we hit play now, Yes, everything's synced up. I've completely done nothing, right? No, this has actually made the project a lot easier to start building. Because imagine you have enemies that more or less have the same, it's just a change of stats. You have like a bestiary. So instead of having all these different prefabs, we just have pure data that we can plug as we wish. Cause so like our bestiary could just list, what it looks like, the health, the attack, and all that's all it needs, and that's all we care about. And like I said, how I was illustrating a point. So what if we change this attack? Oh look, I only had to change it in the scriptable object. It's already updated in the scene. What if I want to change what the sprite looks like? I want it to be a square enemy now. Okay, while the enemy itself didn't update, the stats panel that's pulling data from that scriptable object already did. So yeah, this is actually very nice. So you see how it's much easier to just tune it here and just leave it alone. It's one place to think about. Don't have to figure out where all the different stats are. And now, if I exit play mode, the data stayed. So if I'm still like balancing stuff, the enemies are too strong, too weak, all the changes stayed with me. And so if I hit play again with all my changes, you'll notice the enemy is now updated, the stats are correct, and it's nice to have. So if you all aren't familiar, Hearthstone is actually built in Unity, and I'd at least imagine this is sort of how they store the cards as scriptable objects, because cards have health, they have attack, they have an image, they have a name, and it's just boring data. Why make all these different card prefabs for each individual card when I could just have these scriptable objects that store all the data and the card just, reads it off? But yeah, that's sort of the short of it. Yes, 30 minutes. Any questions, really? Yes.
So you said that scriptable objects won't persist outside of playtime. Like when you're actually playing the game and you've got your inventory, and it won't persist if you quit and then come back to it, right?
So the question is, will the scriptable object persist after playtime? And that is, it depends. So that actually depends on whether you're in the build or you're in the editor. And so this is a very weird distinction, because in the build, these edits to the serialized fields, even if they're in code, won't stay. But if you're in the editor and you're hitting play mode, those changes will stay. So it's both like this benefit and dangerous thing to keep these serialized fields and like edit them.
Alright.
So
you just have to do regular saving to make sure your inventory is in whatever percent, yeah?
yes, if you want to keep your inventory like after you close the game and have it open up normally, if you open the game again, you would actually have to learn how Unity does data storage, I think through JSONs, and like learn how to read it, save the data, and read it from there. So yeah, scriptable objects aren't the solution for saving. They're a solution for just centralizing data and like making it easier to work with.
Is there going to be a class about saving, or is that something we have to learn on our own?
There currently isn't one planned, maybe. um, but yeah. Any other questions? Um, so just to sort of link it back to older classrooms, I've actually seen examples of building your events using scriptable objects. So now you're like, how the fuck do I do that? Because this is just pure data, but you know what the data can contain is you can contain event data, like you can contain actual like at a Unity event in this scriptable object. So now you're like, why would I do this? So if you have a Unity event and like you have all the functions you need to call are just in the same prefab, it's no problem. Just directly talk to them. But what if it's on a different object? So for example, let's say I want to have like a special event trigger if the player gets damaged 10 times. So like that trigger, I'm not going to put it on the player. I'm going to put it on something else. So I know this is a very like hypothetical situation, but stick with me. Um, so what I could just, have the player on damaged tell that other object, hey, I got damaged, do whatever you want to do. Or I could punt that call to a scriptable object event and say the player just talks to the the on damaged event. And then whatever, hit counter is wants to be tracked, they can also just listen for events on that scriptable object. So now, because let me rephrase this. So so it's a player prefab, right? The problem with the prefab is that if you want to else, link to anything else in scene, you have to either have the player in scene or like um, be on the prefab itself. And so you don't have to have this direct link if you have that scriptable object. You just punt it to something else that's, neutral ground, and then other things can listen to that. Does that example sort of make sense at all? But yeah, that's all I have for scriptable objects. Short thing because it's basically just data storage. So that's it. No questions.